Okay, so we kind of did some introductions about VirtualBox in the last lecture. What I'm going to do this lecture, or I should say for this week, is we'll actually play with some of the tools that are useful for a cyber attack. So today we're going to go through a handful of things. We'll pick up some of the concepts that are a little bit more advanced in VirtualBox that allow you to build your kind of test environments. We'll play with some of those. We'll actually use them in simulating this cyber attack today. Basically I touch on these 6 points, or the 6 points that I'm going to cover today as far as class goes. So I've already pulled down the VirtualBox images. I'll show you where I got them from. We will look into these two topics inside of VirtualBox, the networking and shared folders features. We briefly touched on them last week. I'll actually show you how I use them frequently in a lot of my attack simulations. We'll use Kali to build a very rudimentary attack, and then we'll simulate delivery, targeting, exploitation, remote access, stuff like that, and then we'll actually start to take a look at the thing that we built to attack ourselves with. So I'm not sure how many times people typically do this, but I always try and do a example like this. Either I'll do a real demo, or I'll at least talk through the steps that occurred for attacks that we've seen in the past where I work. Mainly, one of the big reasons for this is because if we learn how the attackers launch an attack, or we learn how to perform an attack ourselves, it gives us a decent amount of intuition, a decent amount of context and background knowledge, so that when our job is to analyze a malware sample we've been given, where we don't really have a lot of description as to why it exists, where it came from, etc., this allows us to fill in the blanks, so to speak, or it allows us to helps inform our conclusions. We'll see a lot of things inside of the malware sample that we're analyzing. It's our job to draw conclusions based both upon those things and also upon our knowledge as to what an attacker would do to explain what the malware is supposed to do, why we're looking for it, where we should be looking for it, that type of thing. So what I'll use for a lot of the parts of this course that I am trying to pretend to be an attacker for is Kali Linux. It ends up being a canned vulnerability assessment or penetration testing system that's distributed by Offensive Security. So for those of you that aren't familiar with this company, this is actually a real company that's named Offensive Security. They do a lot of really great work. Excuse me a second, I need to drink my tea. And they actually run a lot of really good training courses that typically run people about in the range of like $1,500 to $5,000, depending on what you're trying to get background in. It tends to dive a lot deeper than a lot of the courses you'll encounter at UC, and a lot of the material in their courses tends to be focused on stuff that you would probably see in the computer network exploitation course that we sometimes have here. As with most of the Linux distributions, the live CDs, you can download an ISO image, and we talked through that last week. If you dig deeper on their website, you can actually find that they distribute VirtualBox images as well, which is what I pulled down. I think I demonstrated that briefly last week. We'll go back to their website and navigate all these things today as well. And then I just wanted to also talk through a handful of tools that are included. They actually include probably over 100 different tools that aren't part of any Linux distribution, but they're actually tools that are recommended by a lot of penetration testing experts, a lot of hackers, basically, and also a lot of like vulnerability assessment people, that type of thing. As well as your general like system administrators that want to be able to diagnose problems on their network, things like that. So I picked out like 5 here that kind of give a like broad range of the different capabilities that the toolset has. The first one is the metasploit framework. You can go to the URL metasploit.com, and that's like the de facto tool that you'll see in even a lot of kind of TV shows and movies will use it sometimes, but it's a de facto exploit building tool, attack tool that is prominent in a lot of training assignments. So a lot of the trainings you'll go to will utilize that tool. A lot of great documentation on their website as well will actually pull some pieces from one of their examples for the attack that we're going to launch later on. So in addition to that, there's this other tool called, this one down here, called Armitage. It's actually hosted at a very easy to remember website that's fastandeasyhacking.com. I don't know if it has a more Armitage themed website or not. That's the only one I found linking to it. That tool actually, I'll say, is like a suite that incorporates a lot of the other ones. So you'll install Armitage on a machine that you already have Metasploit framework on, as well as a number of other tools such as Nmap, which I don't have listed here, but we'll also talk about that one briefly, and ping and other things. And so Armitage provides you with a GUI, graphical user interface, that gives you the ability to run, say, network discovery tools and scanning tools. So for instance, if I plug, if I go to, say, a library or something like that that has network jacks in the wall, and I plug my laptop into it, I've now plugged my laptop into a network that hypothetically may have 100 other computers, including laptops and desktops, plugged into it as well. This system comes with a large number of tools that allow you to query that network, see if there are other systems on that network, interrogate some of those systems where they let you, and learn, say, what operating systems are on there, what other services are on there, things like that. Most of those tools are command line based, which means you deal with a large number of text files of output and stuff like that. A tool like Armitage actually provides a all-encompassing graphical user interface that will consume the text-based output, and it'll graphically represent what the network looks like, and it'll run an attack almost inside of a project management system for you. So it gives you the ability to discover what's on the network, make notes about different systems, provide different people access to your view of the network so that they can also provide their input. It's like a project management system almost for attacks. And a lot of the higher end teams that end up having multiple pen testers, multiple vulnerability assessors working in tandem may use a tool like this. So it's worth looking at. I believe one of Dr. Franco's courses actually uses it for one of the labs as well, so some of you might be familiar with it from the cyber defense course, I think. So another one that's offered is PowerFuzzer. What you'll learn, and we'll actually experiment with some of these later on as well, there's what are called fuzzing tools. And these fuzzing tools, what they try and take advantage of is how a lot of applications accept user input. So for instance, you may have a website that accepts, say, user, or I should say first name, last name, date of birth, and maybe a handful of other information because you're trying to register for an account on a, like, movie website or something like that. So all that data that you're storing in the system typically gets fed into a database in the back end. And how it gets fed into the database is the website actually stitches the data that you've entered into queries, so into a programming language that's written for that database, and it executes it on the database. What fuzzers try and do is they try and basically throw a lot of random data or a lot of common attack data at those form fields in a rapid succession to try and see if there's any attempt or if there's any opportunity to confuse the query engine under the hood or the programming languages backing the database into accidentally executing code that you'd want it to execute. There's a lot of tools for that, and it's not just for database applications. In addition to database applications, it can be used with all sorts of other things, such as like audio editing tools and things like that too. For instance, to try and find a vulnerability in a audio editing tool that someone you know might be using, who happens to be a target of yours. So another tool is OpenVAS, or Open Vulnerability Assessment System, I think, or scanner. So that's a tool that attempts to look for a lot of known vulnerabilities, typically network-based and server-based. So you would throw that at, say, a DMZ, demilitarized zone, that has web service installed in it, to try and give somebody an initial assessment of how secure or insecure you believe all their web servers are, or all their mail servers are, and stuff like that. So, and then there's another one, Burp Suite, which is kind of a amalgam of some of the other tools, but a lot of people use it for specifically for targeting web application vulnerabilities and things like that. So it tends to be a lot more of an application-specific tool that's targeted towards helping you more efficiently build exploits against web applications, and also search out, say, and inventory web applications that might be vulnerable. So we'll jump over to Callie's website just so I can go through that little download really quick. So this is like, if I go to Callie's website, it's right here. Basically, if I go to downloads, download Kali Linux, it allows you to get all the, the ISO files here, excuse me. But then also, if you scroll down here, you can get the virtual images. It also, as is the case with a lot of others, this one actually allows you to get the VMware images, the VirtualBox OVA files, the appliances, and also a Hyper-V, which I believe is Microsoft's hypervisor. So if you have a Microsoft machine, you don't want to run VirtualBox or VMware on it, and you're feeling lucky, you can try and use Kali Linux on Hyper-V as well. I don't know if that's even available through our campus licensing. So, but I just kind of wanted to give you a idea of where you can find the VirtualBox images. This right here is what I'm going to be working off of most of the time. And basically what I did is I downloaded it and followed the same process as last week to get it imported into VirtualBox. So right now, I actually have it right here. So this is it imported. Now give me a second, I'm just going to check. Yeah, so let me go and start this up. So I actually already have it running and was actually using metasploit on it for a few things, so this will actually be a pretty quick startup. One thing I will say, let's see, is that typically if you pull down a newer version, or I should say any version of Kali, they have quarterly releases, so every 3 months there's a new Kali image released. Generally, Metasploit releases updates for their exploit kits and their framework on a roughly weekly basis. So anytime you're using it, it's always useful to run this update command to try and update the tool before you actually use it. And then, basically, there's the Metasploit console, and this is it. And, I'm trying to remember. Yeah, so you can go. It's got a command line interface, so it lets you do that type of stuff. So I think I can do like, or something. I don't know. So I can do like help, and it gives you a bunch of different help items that allow you to say what you're going to do. So anyway, so you can do like help, jobs, etc., that type of stuff to allow you to see what's going on. So it's command line based. This is one of the reasons why there's tools like the Armitage one that I was mentioning earlier, which actually I'll give you. I'm going to go to that link really quickly just to. I believe they have a nice like picture of it up there. So. I'm just going to start Firefox, but whatever.
Who develops these tools? I mean, I know Kali is like a company, right?
So Offensive Security is the company that distributes Kali. Let me see. I wonder if I'm supposed to do this, or if. Hang on a second. Let me. Come on. There. Just do that. Sorry. Give me 1 second. I just need to. I think the virtual machine's still on my keyboard for a moment. So hang on 1 second. This one. There we go. Come on. There we go. There we go. Sorry about that. That's one thing you'll have to worry about is okay. I have no idea, but for some reason Firefox isn't. So I can use my so typically they will talk about, say, who, in this case it's Strategic Cyber, so Cobalt Strike, which I guess they more recently changed their name again, yeah. Or maybe Cobalt Strike is just a subsidiary of it. Armitage is put together by Cobalt Strike, which is like a security consulting company. So if you have a company and you're thinking of, say, building your own data center, that type of thing, say you're Procter & Gamble, for an example, just for the heck of it. So Procter & Gamble's not a security company or anything like that. And you don't exactly want, like, your IT staff being directly responsible for deciding whether the thing they built is secure. You want someone else to come in and give a third-party assessment. So Cobalt Strike might be a company that does that type of thing. And that's why they have these tools. Ditto for metasploit, which is distributed by Rapid7. So we can go Rapid7. This company is the company that's that's responsible for metasploit. So you can see they do all these things. And then the last one was Offensive Security. So an Offensive Security ends up being, they do have consulting arm, but they end up being very well known for being training focused. So they offer a lot of training. And from what everyone's told me, it's all really, really good. I have not actually taken any of their trainings. But Armitage, let's see if, so they'll give you something like this that basically allows you, for instance, to determine what's connected to the network, and then you can even, say, compromise different machines, and there's icons for that. So it gives you a visual kind of readout for what's going on if you're using like a metasploit console like this to try and navigate. So now, so I got Kali installed. What I'm going to do is I'm going to do like a really basic remote shell attack. What that basically is I'm going to get some executable code that I'm going to build in my attack machine. So I'm going to build it inside of Kali Linux. And then I want to deliver that to another machine that's running WindowsXP. I'll get to that in a second. And I want the user of the WindowsXP machine basically to open the tool and have it connect. So have it initiate a connection back to my Kali Linux box so that my Kali Linux box will receive a command line interface so that it can navigate basically remote access to the other person's system, and the other person doesn't necessarily or isn't necessarily aware of this. So I kind of give it good 6 steps right here, which is what I'm going to do in Metasploit. And I will say that the system I'm going to attack it's a simulated environment. I'm trying to build a lab that's designed to run and exploit the malware that I have. So if I take that Windows 10 image that I got from UC and all the antivirus stuff that it has on it, plus whatever updates were automatically installed back during the first lecture, and I try and run my exploit on that, probably not going to work. It actually would take me like a decent amount of research. A lot of times if somebody wants to leverage a new zero-day attack, that can take years, or it can take months or something like that. But trying to attack, say, the latest and greatest version of Windows and everything like that, needless to say, is kind of outside of the scope of this class. What a lot of adversaries will do is they will try and survey, say, target environment to try and find out what are the weak links. So have they been lax on updating Microsoft Office, which is actually a common problem. Do they maintain many different versions of Adobe Acrobat Reader because of compatibility concerns? You know, if so, there's a possible entry vector there. Do they have old web servers, things like that? So what we're going to do is we're going to have a really old version of Acrobat Reader and a really old version of Windows, because what I really want to do is attack that, show you the remote access and what I can do with it, and then also still have time to be able to throw at least one tool at the payload that I built to kind of show you what, how I attack it from malware analysis perspective. So let me see this. Yeah. So let me actually pop this up again, and I'll just show you. I will have two links here. That'll be the code, or I should say the recipes, the two recipes that I'll be using for this attack. So I didn't build a lot of these from scratch because I don't have to. The internet has a lot of these things. So this is kind of what I worked with. And also give me a second. I'm going to close that since everyone's here now. It doesn't really help much. But the doors are paper thin here. So I'll get this one, open it up over here. There we go. Yeah. So the internet is infinitely helpful. So the reason I did this is you'll see that these things end up, so I'm going to do this because that's very difficult to read.
Do you have a VPN to get around the clock?
No. What I did was I found that somebody else had, what do we call it, like distilled that website into a PDF and then uploaded that PDF to the internet. So I was going to rely upon that, or rely upon the Google Cache version, which also probably isn't.
Do you have like a home proxy or anything?
Block. I do, but I do not have that set up.
I was going to say it might be good.
Yeah.
Like, that might be a regular pattern.
Yeah. Yes, that's a very good point. So the other thing too is what I should have done in prep for this is I should have just made that site into a PDF myself, which is probably what I'll do when I get this stuff up on the course site as well. So anyway, let me go back to that document, which is right here. So what it allows you to do, it has like a bunch of cool features. One of the ones that it has is a search feature. So that actually allows you to search through the different attack mechanisms that it has. So I can go back here and I can do like search, type, exploit, and it'll go through like the entire module database, and it'll find like all exploits and list them to me if I want. It'll take a moment to run. We'll just give it a moment, but I'm going to jump back to here while it's running. Okay. So we'll jump back here. Let me just see if, nope. Just leave that alone. So we'll jump back here, and what basically we end up doing is we go and look for exploits that we can throw at the particular software platform that we're looking at. So I have Windows platform, and then ones that contain the words Adobe and PDF in them. And then from there, we can actually use it. So it has a state-based system, and this may be very familiar to some of you who've used, say, some of the development environments like Ruby on Rails and things like that kind of maintain like a state-keeping mechanism when you're working on your different projects and everything, or like Python's virtual environments and things like that. So basically, it kind of keeps state and gives you command line access, and you're kind of working within different compartments or different states. So so what it did was it listed all these different exploits. So what I'm actually going to do is the platform, Windows, and then maybe Adobe PDF, and see what they have for that stuff, because that's what we're going to try and put together here. So again, it'll take a moment to search. Some of the documentation does have, like at this right here, the module database cache not built yet. If that ends up becoming a common occurrence for you and it's annoying, you can actually build a local cache for that stuff if you set up like PostgreSQL and everything like that on Kali. There's documentation for doing that. I did not want to go, and more moving parts means more opportunity to break, and I didn't want that. So right here, this gives us two, one of which basically does embedded executable, and then another one which gives us, says what's supposed to be the same thing, except it's doesn't use JavaScript, I guess, is what it's trying to say there. So what I would do is I'm going to go back here and just kind of walk down this little thing and make sure I'm following the same stuff that everything else is. So I'm going to pick one of those two. They picked the embedded exe, so I'm going to pick the same one so that we can be consistent with this demo, which is this one. So basically, do use, and then it goes kind of inside of that exploit, and you can run info. This gives you, so you remember it showed that really long list of exploits before. You can do this for every single one of them. It shows like who the authors of them were. So in this case, Colin Ames from attackresearch.com, which is a different company that does like security consulting work and stuff like that. They have a really good blog at attackresearch.com that is also worth looking at to get an idea of other attacks that they've encountered. It tells you what versions of Adobe Reader it's supposed to be effective against, as well as what versions of WindowsXP and Vista 7, etc., that it's supposed to be effective against. So you can go through here, and you can also very likely search on those criteria as well. How each of these work is that when you use them to try and build an attack, you're supposed to provide, or you can optionally provide, depending on the exploit that you're dealing with, some variables, some of which are pre-populated. So in this case, what this one's going to do is you're going to create a PDF, and when that PDF is read by a person, it's going to get opened by Acrobat Reader, and then Acrobat Reader is going to display a message to the user that says something. So for instance, in this case, this is what content is going to be shown in that message. So in this case, it's going to say, to view the encrypted content, please tick the do not show this message again box and press open. So that particular thing is going to show a box to the user before it probably shows them another box. And that's supposed to try and convince the user to change a setting in their Acrobat Reader for, say, the future, maybe in prep for a future attack, that'll make their version of Acrobat Reader less secure. So in conjunction with just like malware to be used for, say, attacking people, a big strategy that's used by a lot of adversaries too is to try and figure out ways to convince the user who's the target to weaken their security of their environment or weaken their attack surface, that type of thing. It also allows you to pull the PDF that it's going to get the data from. We're just going to be really easy here, so we're going to just pull in the default one, and then what the file name is, and then the exe name. So you can provide a exe to it, the actual exe file to it if you want it to run some sort of random program or run some sort of like calc.exe or something like that. So we'll follow the example here. Yep, reading free preview. So I might have to set up the default thing, whatever. So give me a second, I might just have to pull down the original. Just do the PDF. So this is the one I was looking at. So what I'm going to do is this one maybe. Yeah, here we go. So set target, exploit, etc. Wish I would have this down, but let's do. Let's do this one, I think. So here we go. So I got the exploit. This one's doing the Node.js one. I'm going to actually do this one. So and then let's see. So I believe this will allow me. I just want to make sure that this is the same payload I'm using here. So give me a second. Bear with me. We have like 40 minutes, so I should have time. But yeah. The goal here is that I need a PDF. I need something that Acrobat Reader can open. I also need code that I'm going to try and convince. I'm going to try and confuse Acrobat Reader into running on my behalf. And so that's what the payload is that they're talking about here. So you can see like there's a whole bunch that are here, right? There's Windows 64-bit interpreter, like reverse TCP and all those things. Let me expand this so it's easier for you to read. So what I'm going to end up doing is I'm going to set payload to what this person has on their copy here, Windows interpreter reverse TCP. So the difference here is that one approach that I could take when I'm attacking someone is I could attack them and then get them to open up a listener on their machine so that I can connect to their machine. Since most people today, like you at UC, you're behind a firewall, which means that if I'm anywhere on the internet, I can't find any one of your laptops on the UC network. I just get to see the egress point, the exit point for all of our network traffic from UC. So to get around that problem, we do this reverse TCP thing, which is I give you something, and instead of listening on your laptop, my server that I set up in Amazon or something like that that's public, that's what listens, and your laptop goes and connects to that and gives me a connection. So that's the way that I'm telling it to work here, and I'm just giving it the default one that metasploit comes with. So this is a special protocol that's designed to be able to provide you access using the metasploit console here. So I did that, and then let me go over here. So I can set the file name if I want. The other ones, so let me go to info again, and you might see that difference. So, let me see if I do. Oh no, it's options. There we go. So options. So what options allows me to do is allows me to configure this. This shows me the options from the module. So these are the same options that were described in the PDF when I hit info. This one down here is actually some configuration options that are for the payload. And basically what's here is this one's how, I'll get into this later because this is some Windows internal stuff, but it's basically a mechanism it's going to use when the exploit code runs. This one here is which host I want to connect to, so where I'm listening, my public Amazon web server that I set up. And then this one here is the port that I'm going to be listening on, the TCP port. So if I'm just going to be launching the attack from here, what I'm going to do is I'll just do ifconfig to find out what my IP address is. I may not want to use that because that was like a DHCP. I'll show you in a second. It was sorry. That was a DHCP that was assigned by the NAT networking. So what I'm going to try and do with this, because I don't want to accidentally leak any traffic out into the UC network or anything like that, I want to make sure that all this stuff stays internal. I'm going to go to internal network, and then I'm just going to give it like, a name like hack and then the date, right? And then what's today, like the 17th? Yeah. So I'll give it that name. If you look down here, it actually shows you, whoops. It actually shows you like the different networks that are available. And then what I can do, what I typically do is this. Stop the network manager, and then I'll manually set up a networking connection. So ifconfig. We'll set this to number 12. So now I've got this IP address on this system because we're simulating an attack again. So what I'm going to do is I'm going to take that IP address that I just configured my interface to have, and I'm going to set that to be the L host or the listener host for the payload that I'm giving. So that's what's going to be embedded inside of the payload is instructions when Adobe Acrobat opens it, gets confused, and then runs this arbitrary code that I have like stuffed inside of it. It's going to have instructions that get it to try and connect to my Kali Linux box here. So then, finally, what I can do is I think I just run exploit, and yep. And it's really that. So now a brand new PDF has been created. And then my next job is how do I get that PDF over to the WindowsXP box. So let me see. Yeah. So yeah, I gave kind of like a little use case right here, demonstration use case right here that might be worth worth thinking about. Since I can give it any PDF, like I don't have to give it the PDF that comes with Metasploit, I could go on the internet and try and find a PDF. Might talk about like the Bengals, or might talk about like good places to eat in downtown Cincinnati or something like that. Tailor it to whoever the person is that I'm trying to send the PDF to, that I'm trying to get to open it, and then I basically am stuffing executable content inside of that. So they're going to open it. Think it's what they want, and it's actually going to be something else. So it'll be an attack. So now, let me go over here. The second step, because now we have the PDF, right? The second step is going to be that I actually want to configure a listener to run. So what I'm going to do is use this exploit multi-handler. And what this is this is basically a handler, a listener, for a lot of those different payloads that you saw. So if you saw when I just searched for the payloads that had reverse in them, or TCP or whatever I was looking for, there was a huge list of them for all sorts of different Windows configurations, all sorts of different application configurations, stuff like that. The way Metasploit is set up is supposed to be a multi-tool for a lot of these things. So now what I'm going to do is the second half, which is use exploit, or sorry, exploit multi-handler, exploit multi-handler. So now you can see that this thing is now changed from me working inside of the Adobe PDF embedded exe exploit to a new kind of tool that's called the handler, which is the name for the connection handler, basically. And then what I'm going to want to do is I can do the same thing, set the payload to be Windows shell reverse TCP. We'll see if this works. I might have, oh, if it doesn't, we can just make a new PDF. And then, yeah, and then I can just do show options or just options. So then what I'd want to do is I'd want to set lhost again to the same thing that I put in the payload for the PDF. And then, let me see. So they have a whole bunch of other things that you can do here if you want. I'm not going to go through all of them, but I went all the way back to the top for whatever reason. You can change the port as well, but basically once you have everything set up, you should be able to run exploit. Yeah, and the one thing that I might have done wrong, and we'll see, is I'm not sure if this should have been Meterpreter or not. So we'll see. So now what it's doing is it's actually listening on that port. And what I'm going to do now is I'm actually going to go over here to where I have WindowsXP set up. And I'm going to also mess with its network settings. So this is how I put both of them on a common closed network, is I give them both this network name that I just created today, so that now when this one starts up, it's going to be sitting on the same network as the other one is. So what I'm going to do is I'm actually going to go here. Control panel somewhere. Here we go. Sorry. I'm going to go to the network settings and mess with that. Oh, come on. Windows is getting confused about, but oh, there we go. It just took forever. I have no idea what the problem was. So I'm just going to put this one on here. So again, what I'm doing is I'm putting together a simulation lab. So I want to put them on the same network and also have their IP addresses so that they can communicate with one another. So that's what I'm doing. I'm just going to set up static networking on both of these. Once I have that done, this sometimes takes a while. Once I have that done, I want to share the data between the two of them. So what I'm going to do is I'm going to use another feature that's in VirtualBox that's called shared folders, which is right here. What I'm going to do is I'm actually going to do source malware. I'm going to share this folder between both of them. So this allows me to connect that folder as something that can be seen by this Linux instance. So is seen almost like a device. VirtualBox, one of the features it has is it gives you the ability to provide folders almost as like mount devices without having to simulate an entire disk drive or having to set up a Windows like shared folder networking type of thing. And that's what I'm going to do right here. I'm going to do I'm going to create a new folder, and you'll see in a moment why I picked this particular folder name. But what I'll do is I'll do mount vbox, whoops, if I can type correctly, shared folder, so vboxsf, Acrobat installs, Acrobat installs. So the folder name on my hard drive is Acrobat installs, and that's what I gave. That's what I gave it, or I used the same name when I set up the shared folder here. So it tells you the name's here, and then the absolute path is here. This name that's in the first column is the one that you'll want to use down here. And then the name, the folder that I created, so I could have just called it A if I wanted, is the second parameter. And so now I can go there and I can see there's a whole bunch of stuff there. The other reason, one of the big reasons I'm trying to set this up here is because I want to get that I want to get that PDF over here so that it's on my laptop, so that I can then do the reverse of what I just did on the Windows environment to get it into Windows. The other thing that you'll notice I have here is I have a whole bunch of the free installers for versions of Adobe Acrobat Reader between 11.01 all the way up to 8.1.0, and then everything in between. So if you remember when we were looking at the documentation for our exploit, it looks like this one and maybe these, and then this one are all potentially vulnerable to the exploit that we're trying to throw at it. So then I'm going to do the same thing in here, which is I'm going to go up to devices and I'm going to say shared folders. The shared folders operation in Windows works a little bit differently. Connecting it to the virtual machine works exactly the same. Let me just do this. Here it is, that. So again, I do that. But in Windows, because you don't exactly have command line like you do in Linux, what they ended up doing was they tried to make it behave in much the same way that a shared drive in Windows works, which is, well, yeah. We'll see if this actually, if it doesn't show up here, I can actually just go here, which is vboxsvr. So vboxsvr ends up being the host name. So those of you who are familiar with Windows machines and Windows networking might recognize what I'm doing here. But for everyone else, what this is basically if you have a network of Windows machines and they're sharing files, you can actually inspect many of the Windows machines on the network by simply putting in / host name and then another /. And then I can navigate all the things. So what VirtualBox does is it actually creates a fake server, a fake file server, that then is interpreted automatically to have all the mounts that I listed in this little thing. So this gives me the ability to move files very easily between my VMs and my lab environments, and even share files among them without causing network traffic between those machines as well. So this means I can drag and drop files if I'm trying to analyze network traffic and everything like that. If I set up Windows networking, or if I used SSH or something like that, then I would have a huge amount of network noise that I'd need to clear out of whatever I was doing monitoring on. This provides me basically with an easy button to not have to deal with any of that. And then I can go in there and we'll see if it, there it goes. It just sometimes takes a moment. And you can see the PDF is here, and you can say like, aha, the PDF isn't even recognized as a PDF yet. And that's, yes, that's the case because I don't actually have Acrobat Reader installed on my Windows system at all yet. So what I'm going to do is I'm actually going to pull this in here, and then I'll pull this guy in here, and then I'll close this. And I'm going to install Acrobat Reader really quick, which shouldn't take too long. This is a pretty decently fast machine. But this is what I typically do for a lot of my lab environments, because there's all sorts of different versions of Acrobat Reader and everything out there. So it's very important to maintain these libraries of installers for all the different versions and everything like that, because that allows you to try, say, if you're analyzing malware, if you get a piece of malware that's in a PDF and you don't know what's vulnerable to it, you do have to set it up so that you run it through a whole bunch of different versions of Acrobat Reader or Microsoft Office or whatever to try and determine what's vulnerable to it, what isn't. And that gives you a picture of what's installed on your network that you need to remediate versus what can you leave alone untouched. Because that's really what you're trying to do when you're doing malware analysis, is learn what you can about the malware so that you can tell the people you're working with what actions they need to take to try and mitigate the vulnerability in the network that this malware targets. So then, there we go. So now it's installed. So now I'm going to do one more thing, which is always very important, is verification, which is let me make sure that my IP address is set here, and then also make sure that I can talk to the other machine that hypothetically I constructed an internal network for the two of them to talk to. But we're all human and we make mistakes, so it's always important to validate. So then I'm going to go back here and I'm going to see what happens. We may have to rebuild the exploit, and this, if we do, it'll be a good example of just how quickly the exploit generation feature or sequence is in this. But let me go see if I can find my Windows system. I'm going to try opening this up. So of course it goes and gives me the warning about all that stuff. And then it goes and gives me an option to save this. So it's what it's doing is the code that's built into it actually attempts to write another PDF to disk that would contain the information that, like you can see this one says template. That actually means template.pdf. So if you remember when we built the exploit in the first place, the in file name variable was actually set to template.pdf that was buried inside of one of the metasploit directories. So this is basically the PDF that you want the user to think they're looking at. And it goes and does this. I can't exactly remember why this exploit has that extra dialog box feature. But like any good user, I just clicked OK and had it do the thing because I want to see what's in it. Exactly. The other thing, too, is this right here. Remember I went over that text that goes and is shown to the user, and you can configure what that says. So this thing right here is basically telling me to check this box off, which means that I will never get this warning again. So I'll go ahead and do that because I want to, and then I say open, and then it goes and does something. And you can see down below on my Kali thing, we're kind of going, you know, we're the adversary and the client at this point. I just had some activity occur down there on the thing that was listening. And what it does is it's providing me command line access to the Windows machine. So now I can, dir, I can, if I want to, I can start pulling more tools over to it and things like that, or I can start, uploading these different things to a new website and everything. So I can go to, temp, or I don't remember what all's in here, but Windows temp, right? It's been so long since I dealt with this old. So I can start, was it type? Is it type hello? No, it's echo hello, yeah. So see, and then I created a new file on here. So I have write access to the user's machine. I basically have all the rights that the user has, and I just did a whole bunch of actions, and this user doesn't see, is completely unaware. They're just looking at the blank PDF. If I had given them a PDF that said that had cat pictures in it or something like that, they'd be looking at a PDF of cat pics. So in this case, I just use the default things to try and simplify it. So, so that's like a very lightweight attack. I'll make sure that the sequence of steps I did use today end up actually being go into slides, and we're not reliant upon those websites that UCIT has flagged as malicious, which is probably a good thing. What I'm going to do is I'm going to exit out of here now. And then I'm going to exit out of the metasploit command line. And that, just goes back to disk. So then, yeah.
If you turn off that Windows machine and run it on again, so can we access it through that backdoor again?
So that's another feature that you can do. It's really common. So if you were to, so that's a program that's running on Windows basically that's giving me command line access. So if I got it written to disk and then it executed that one time, then it's not going to start up again unless I manage to put it somewhere in my Windows system that'll allow it to be restarted on restart. That's a really common way. They call that persistence, and we'll definitely dive into that. So just like you can install services and drivers in Windows, you can usually install little tools like that, little backdoors, as services and drivers. Or really common approach that's your most straightforward one is this one. So pretend that I'm back on the command line again, right? In fact, right here, hypothetically, what I could have done when I was at the command line earlier and it had access is, let me go into the desktop, right? What I could do is I could copy that PDF again into user, come on, where is it? There you go, start menu, programs, startup, right? So I get that PDF in there, and now every time it gets rebooted, as long as I have that server running on that IP address, then I'll get it to reconnect on reboot. And you can also see that's the same thing as if I was the user, just trying to put it over here in the startup menu. See, so that's a really quick and dirty way that a lot of people will do it. Now that PDF, it's going to be pretty obvious and obnoxious for the user, but as you saw, there wasn't a window or anything that popped up for the remote access tool. So hypothetically, I could get that remote access tool in the startup, and then as long as the user didn't navigate here, and probably, many of you, if you're like most users, you've probably almost never hovered over the startup menu in Windows. It's actually valuable practice to do it, from time to time anyways, just to give yourself a very simple self-assessment. But they rely upon that, and I've seen that approach used very frequently, probably half the time. Just because it's also, this happens to be one of the old legacy Windows 95 features that's just been compatibility with this approach to getting programs to start on login has just like been something that Microsoft persists with every single new revision of Windows. So that's one example of very, very simple, straightforward persistence, but there's a whole bunch of other creative ways that they'll do it too. So,
so wait, is 99% of hacking just using tools like metasploit puts out and exploits that they put out? Like, I mean, like, people call themselves actors and then they just use these tools typically?
A lot of actors use the tools. I can. Metasploit is an example of a tool. There are other tools like Metasploit. What I've seen is a lot of the more organized teams, they tend to have their own Metasploit-like database. But I mean, tell you the truth, a lot of the attacks that I see on a regular basis are stuff that at least parts of it were constructed with Metasploit.
Yeah.
Yep. So, and it happens to be...
That's kind of a letdown, I gotta be honest.
So, I mean...
Like, I really have to picture in my mind it's like actually like creative. And
I will say that that the hacking or cyber attacks are very much like advertising, right? There's so much of it, like it's so noisy, and so the majority of it is just like advertising. The majority of advertising is stuff that's not targeted to you, and it's not interesting or it's not useful, right? But there's little pockets here and there's like one or two things that are marketed to you and everything like that. Same's true with cyber attacks. Like 90% of cyber attacks also probably don't work on your system and aren't targeted to you, and they don't care if they don't get into your system or not or anything like that. But there is someone out there, or there is a few networks out there that are vulnerable to it. So
another question I had was as far like you mentioned before, like it takes a long time to have to do research and like finding what exploits will work and what because they don't know the environment they're dealing with.
Exactly.
Right? Like, they're just trying to find what environment they're dealing with.
Yep.
So isn't that like in a way revealing of them?
It can be, yeah.
Like if I'm just going to town and trying to get into GE's network, I mean it's fairly obvious that some guy is like running buzzers and God knows what else, SQL injections and
Yeah, exactly. So those things, and that brings up a good point. And that's where the lab environments, like what I was setting up here, they come in they're used very heavily by the attackers as well. So you'll try and go to say, I don't know, we'll try and go to a website. Like I can go here and I can go to like, someone's WordPress blog. This is probably, thank you Firefox for not allowing my keyboard for some reason. So we'll do like someone's like WordPress, right? This is gonna give me like random people's WordPress or whatever, right? Or something, I don't know. So here, you can go here. This thing talks about WordPress. Like if I was to go around here, I can use a bunch of different hints in here, like I look just like a normal user right now, right? Like I'm not doing anything bad or whatever, but if I go in here and dig through here, I can find out like what version of WordPress they have installed. I can probably find out what Linux server they're running it on, what Apache server they're running it on. Then what I'm going to do is I'm going to set up my own little lab, and then I'm going to install all those things on the little lab, just like what I showed you today that's got an internal network, and I'll hit that thing with all the noisy stuff. And then I'll try and see if I can find an attack that works against that. Once I find like a handful of things that seem to work against that, then I might try and pivot back to the other system, maybe even taking the opportunity at a certain high traffic time of day when I feel like I'm more likely to fall like underneath the noise, or not the noise floor, but the underneath the normal user traffic and all that stuff. And then there's a lot of tools that allow you to set up all sorts of like throttling and stuff like that. So I could have my attack go for 8 hours and then do only 5 things over those 8 hours, interspersed with like an hour and a half in between each.
Gotcha.
So there's all sorts of like creative strategies, and that's kind of where I like to say, what was it, like this little thing right here. It's like with the right tooling at adequate time, like no matter what, attackers demonstrate that all fixes and mitigations are temporary. So like even when Windows 10 came out, there was a feature that was in Windows 10 that allowed multiple Windows 10 machines on a common network to actually share Windows updates between one another. And I don't know what the end result of this was, but I do know that as soon as that came out, a bunch of people on a number of the security research blogs were like, this has to be hackable. There has to be some way to use this as a way to convince somebody's Windows system that you're giving it a legitimate update when it's actually getting malware. And then they went to town on it. Microsoft released the whole feature as something that was completely secure. But like so many other things, they always end up having someone who figures out how to work around it or how to make it insecure. And that's because it's a combination of the technical flaws that are in there, but also the user flaws. The fact that if I spend enough time, I can convince most people to open something that is meant for them maliciously. I have like one friend that does a lot of like security tweeting and stuff like that, and they said that whenever I've had to do a targeted phishing exercise, I've never not been able to exploit the target. I've never not been able to get a clicker.
Right.
So, and generally that ends up being like very targeted, long period operations. So you're given a month to go after a team of people at a company or a handful of people at a company or something like that. So instead of jumping into the PDF tool that I was going to do here, because we only have like 5 minutes left, I'll just end the lecture for today, and then we will pick up on that stuff and analyzing the payload in the next class. And then in addition to that, I'll also probably have a couple of different payloads that we can look at too, which is what I was planning on doing. And we won't be diving deep or anything. I'll just be kind of showing you kind of I'm looking at it and saying, this looks odd, this looks fine, etc., that type of stuff, and explaining why. So, cool.
So 2 questions real quick.
Yep,
right?
no problem.
Talk about the class. You're recording these, right?
Yeah.
And then the second thing is, our Blackboard is still not available. I didn't know.
I haven't.
You do that, or?
I need to do that.
Okay,
I don't.
No, that's fine. I just wanted to make
Sorry. That reminds me, I mentioned midway through the lecture, I'm going to be hosting a bunch of stuff on GitHub, but I will also replicate a lot of the content, or at least link it in Blackboard. Blackboard will still be where all the submissions will go and all the homeworks will be posted. So you'll use Blackboard's homework interface to submit assignments. But those assignments will also be posted online publicly where the lectures are. So I hope to either get an email out to you guys or just like talk about it at the next lecture when I get all that stuff together. So yeah, I just
thought it would help. Like,
yeah.
We wanted to start going back over a little bit, just kind of scan the presentation.
Yeah.
That like before it built up too much, that like we could do like
okay.
pretty soon at least.
Yeah, no, that's a good point. I want to get it up this week, and then I want to have something that you can at least experiment with this stuff on that we're talking about up by the weekend that you can work with.
Okay, cool. Thanks.
Cool. Anyone else? Right. Cool. Have a good one. I'll see you in 2 days.